Welcome to another exercise for the workbook statistics. This time I'm going to talk about measures of central tendency, or to be more precise, I'm going to talk about quantiles, quartiles, percentiles, and everything I need to construct me a box plot. Because that's also our task here, we're going to consider the data for 10 randomly selected posts of an influencer and the respective likes thereof. So that's those 10 observations here, and I'm asked to calculate based on the data for the like numbers the statistics I need for the construction of a box plot. So exactly what I mentioned earlier. Well, before I'm going to calculate any statistics, I'm going to take this data set and I'm going to reorder this. So I'm copying this, then I'm reordering this in an ascending fashion. In other words, I'm going to start with the smallest numbers, increasing these numbers continuously until I arrive at the largest number. So here this data set goes from smallest to largest number, because working with this ordered data set makes the next part much easier. So for the next part, we're going to use the same ordered data set. I'm going to start with the 5 statistics I need for a box plot. The first statistic, that's actually the smallest one, that's the lower antenna or lower whisker, and that's given by the minimum. So the smallest value or the first value in the ordered data set, which here is 0.8. Then I'm going to get the first quartile. First quartile would be the lower bound of my box. Here it's also the 25% percentile, which I'm going to get by first off multiplying the 25% or 0.25 with the number of observations. Here I have 10 observations, so I'm going to multiply 0.25 times 10 gives me 2.5. 2.5 is not an integer, so I'm going to simply round this up, giving me 3. That's actually what those half brackets stand for. This means I'm always going to round up, independent of what's after the decimal point. I'm going to round up, observation 3. So I'm going to check my data set, observation 3, that's 8.7, so 8.7 is my first quartile. So I can continue with the median which usually is like a line in the middle of the box, or somewhere in the box. The median depends on whether I have an even or an odd number of observations. As I said, I have 10 observations here, so I have an even number of observations. In this case, I'm going to take the 2 observations in the middle, which here are the 12.2 and the 19.7. I have 4 on the left, 4 on the right. I'm going to take the average of those 2. Or I could go via this formula, which means 10 observations, so 10 divided by 2 gives me 5. Plus 1 gives me 6, so I'm going to take observation 5, observation 6, adding them up, multiplying them with 1/2, which is exactly the same as taking, with an even number of observations, the 2 in the middle and getting the average of those 2. So here I get a median of 15.95. Then the next part would be the upper boundary of the box, which is the third quartile. And the calculation is similar to the first quartile. However, I'm not going to use the 25% part here, but the 75%. So I'm going to multiply 0.75 with 10, giving me 7.5. Again, that's not an integer, so I'm just going to round up, giving me 8. And I'm going to check the 8th observation in my data set, which here is 24.3. So that's the upper bound of my box. Then I'm only left with the final 5th value, and that's actually the largest value in the data set, or in the box plot, that's the upper whisker or upper antenna. So the largest value in the data set, that's the maximum, or in my ordered data set, simply the last value, which here is 31.4. So this concludes more or less my box plot statistics and therefore also this exercise. So I hope you enjoyed it I say goodbye and see you next time.